Hi, I'm Grant Hebert from Valid Manufacturing. Today I want to give you just a brief overview on how to start up and shut down one of our TwinGen 100 series portable generator sets. This is the end where you're going to do all your, make all your connections. We have the displays and the controls under this panel, obviously all your receptacles there, and inside are your breaker panels. We're going to get to all that in a minute. First of all the instructions that I give you today are already right here on this placard, right beside where you're going to stand as an operator. So at any time, you just simply have to refer to these steps and they'll get you up and going. Okay, we're going to go around to the back end of the machine. We're going to start back there. Okay, down at this end of the machine, we obviously have the light mast. But inside this door we have the battery tray, and we need to turn on the battery disconnect before we provide power to everything else in the system. So we'll open the door, turn on the battery disconnect. Our service lights are now active, and we'll close this door back up. Before you start the engine, it's always important to raise the light mast up, at least to clear the engine air exhaust vents. Always look above, make sure that it's safe to raise them. We're in a fab shop inside a building. I can't raise it to full height right now, so I'm just going to raise it up enough to clear that air outlet. That'll do for here. Now I want to go back and I actually want to turn the individual disconnects on for the engine that we're going to start. Alright, so we'll just go to the next door over. Okay, we'll just open up the side door. All the doors have latches on them, so I can latch this door out of the way so the wind doesn't catch it. The doors are also acoustically and thermally insulated. They're a big part of why the unit is so quiet and why we have such a good control of our air temperature inside, which we'll get to later. So this is the left-hand engine. The right-hand engine is very similar. We just hand all of the components opposite. So we present everything on the left-hand side of this engine. We would similarly present everything on the right-hand side of the other engine. We have positive air shutoff. So if the engine does overspeed, the air shutoff will close it off. We have an oil makeup system. It combines the oil reservoir, which has 12 liters of oil in it, with a Murphy low oil switch makeup valve combination. So we'll constantly keep the oil level in the oil pan at optimum level. Webasto diesel fired block heater on this engine only. It's optional on the other engine. Basically, once one engine is up and running, the other engine heats up quite quickly anyways, and I'll show you that in a while. Primary, secondary fuel filters with a priming pump right on the primary filter. Fuel fill on this side. Fuel fill is available on both sides. Again, oil filter is available to us. And the big thing here is the disconnect switch. If I'm going to want to service this engine, I want to be in the off position and have it locked. That's the only thing preventing the engine from starting. That's your safety switch. We're going to turn the switch on, and then we're going to go to the other end, fire the unit up. So we can close the door. Okay, so we have the battery disconnect on. We have the engine disconnect on. This is our air intake for the engines. We need to open this intake cover or the engines can't breathe. So it's just a matter of popping 2 rubber latches, lifting it up. If you forget to raise this air intake, there's a switch right here that won't let you start the engines if the intake cover's down. Okay, so we're going to lift that up. Now we're going to open the operator cover, and it just sits on one latch there. And all of our controls are now available to us here. This panel has all the circuit breakers to control all the receptacles, as well as circuit breakers for the lights. The individual zones on the panels are color-coded. For example, our 208 three-phase area is all blue. Our 208 three-phase breakers are blue. And we have all of the circuit numbers printed on the labels here and here. So if I want to shut off the top left receptacle, I'm looking for 13, 15, 17 circuits, I can easily flip it on or off. They're laid out basically geographically the same as the receptacles. Top left receptacle, top left breaker. If I go down to the 480 volt receptacles, left hand receptacle, left hand breaker. And the lights, you can't see them from where you're at, but we'll take a shot in a minute here, but the light breakers are here as well. Alright, so that's basically what I have to do. I turn on the generator breaker for the generator I'm going to run. I can turn on the 208 transformer. That will provide 208 volts to the three-phase side. The generator generates in 480 volt. In order to build 208, we go through a transformer that's over on this side. I'm going to turn that side on, and that's probably all I want to do. Okay, now I've got to figure out how I want the unit to operate, because this, you can run the unit in a couple of different modes. The first mode is to run basically as a single 100 kilowatt generator with backup. So what you're going to do is you're going to set one engine in auto, and you can leave the other engine off. And that 100 kilowatt engine will put out up to 100 kilowatts. The only time it will switch from one engine to the other is in the case of a low oil pressure, low coolant level, high coolant temperature, something that we've picked up where the engine is not healthy. It will do an automatic switch, and when it does that, the second engine will fire up. It will put itself into a run mode. It'll synchronize on, and then the failing engine will shut down automatically. So basically transfer the power from one engine to the other with a seamless transition. That in itself is pretty cool. The second mode you can run it in is an engine priority mode, and what that'll do is it will run a single 100 kilowatt engine up to about 75% of prime. 100 kilowatt, let's say that's 75 kilowatts. So at that level, the second engine will automatically start, synchronize, come online, and now the two engines will share that load. And that load can continue to climb up as high as 200 kilowatts. If the engine load drops below 60% of prime of one engine, in other words 60 kilowatts, and it remains below that for 15 minutes, that second engine that came online will automatically transfer its load off and then shut down and leave the first engine running. And that's great for a camp situation where you've got loads, small loads that keep adding up over time, but there's no real huge loads get applied. Basically the loads fluctuate throughout the day, and the one engine will run and the second engine will come on and off as required in order to keep things running. The third way of doing it is full 200 kilowatt prime power. That's where you have a large load that you know you're going to want to apply to it. You know that you want both engines running, and you set it up that way ahead of time, knowing that big load is coming. So in any case, what you're going to do is you're going to go to the selector switch and enable the generators. No generators are going to run unless I got that key switch in the on position. And that's just a security thing. I can turn that off, I can take that key out, nobody can start these generators. We'll put it in, turn it on. In this case, I'm going to leave engine number one on priority mode, and I'm going to put engine number one controller into automatic mode, and it's automatically going to start the engine up. Bit of a key sequence to go through. My own personal preference, I always like to hit the alarm reset button in case there's a leftover alarm from something else. Stop, reset, and then auto. And that's all you got to do. Those three keys, that engine is now in auto, and you can leave it there. Going through a startup delay. Preheating, it'll preheat for 10 seconds. It'll turn the fuel solenoid on and fire up engine number one. Okay, when it starts at a low idle, about 1400 RPM, and it's running about 45 Hertz. It's not pushing 45 Hertz out to here because the contactor hasn't been pulled in yet. It's going to run in that low idle, we call a smoke limiting run, just so it doesn't put out a lot of of smoke, and it gives the engine a chance to warm up. So it's going to do that for 60 seconds. We'll come back here in 60 seconds and watch it ramp up. Okay, we're approaching the 60-second mark. There it comes up. Come on, 60 hertz. Contactor just pulled in behind me. We heard a click there. And we're now putting power out to the receptacles if I've got the breakers turned on. This unit is now up and is available to us up to 100 kilowatts. If I change my mind after it's running and I say, well, you know what? I want to run in priority mode. In other words, I want that second engine to come on if my load increases. I don't have to shut everything down and restart. All I've got to do is go to the second engine and put it in auto. Now, if the load comes up to 70% of prime, this engine will automatically come on and start. Or, if somebody says, I've got a big pump I need to bring online, I don't think your 100 kilowatts is going to be enough to hold it in, or you're not sure whether it's going to be enough, I actually want to run both engines. So once they're both in auto, I can leave those buttons alone. I can ignore the buttons. I can do everything from this one selector switch. So right now we're on engine number 1 priority. If I want to run both engines, simply turn it to both. This engine is going to automatically go through its startup procedure, the 5-second start delay, followed by a 10-second preheat. And it'll automatically come up to speed once it's done. Okay, it's up to speed, and similarly, it has a 1-minute idle time as well. So again, it's a situation where we know that the load is coming, we want to turn it on ahead of time, we have time for that 1-minute ramp up. If it were in priority mode and we got up to our magical 70% of load and the other engine decided to come on, it would skip that 1-minute idle time. It would automatically come up to speed as quickly as possible to get online. Okay, so now we'll just take a look at what happens once this comes up to speed. Alright, it's ramped up. It's now coming up to 60 hertz. What it's going to do now, though, is it's going to go into a synchronizing unit. And it's going to work. It's adjust the speed of the generator until the 2 generator sets are synchronized. Basically, you can watch it. You watch this little puck in the middle. It's going to move back and forth. Once it's in the center, the second contactor pulls in. These 2 generators are now both online. We have 200 kilowatts available to us. Okay, so both engines are running, fully synchronized. We now have 200 kilowatts available to us. We apply our load, our big pump, let's say. We had to turn this big pump on. We needed that 200 kilowatts available. The pump is now, it's on, it's running, and the load is dropped to, let's say, 30 kilowatts. Even with the units running with both engines, I can now change my mind again and say, okay, I'm going to go back to either an engine 1 or an engine 2 priority. In this case, I'm going to switch to an engine 2 priority because I don't have a load. It's telling me now that 15 minutes from now, as long as our load hasn't gone back up again, engine 1 will in fact shut down and wait for the next time it's required. And I can switch back and forth as much as I want. I can immediately switch back over and put number 1 in priority. Now this guy's going to shut down in 15 minutes. I can put them back in both. They're both going to stay running. You can move from position to position while it's running and not have any detrimental effect. Okay, so what I'm going to do now is I'm going to shut the engines back down. We can be a little quieter, and we'll just go over a few other key features. Shutting them down is basically exactly the same as starting them up. I'm going to go in, I'm going to turn off the circuit breakers to the loads, make sure there's no loads left. Once I have my breakers turned off to my receptacles, I'm going to come back out to here. I'm simply going to push stop on that engine. I'm going to push stop on this engine. The disconnects fired for both. Each one is going to go through a 60-second cool down, and then the engines will shut down. Okay, so I'm going to shut them down. I'm going to go back around the side, and I'm going to show you a couple other features inside. engines have shut down. It's a little quieter in here now. But I wanted to talk a bit about our air handling system as well in here. So we have a baffle plate here, and unfortunately with things shut down you can't really see it move, but there's a pivot shaft across the top, and this whole plate will swing from this position right up to this position or back again. There's an electric actuator up inside that will swing it back and forth. If the temperature inside the generator enclosure is 25 degrees Celsius or higher, this plate is down and pinned and closed off, and all of our engine cooling air comes into this chamber, up through the exhaust plenum, and out to atmosphere. If the temperature in the enclosure drops below 10 degrees Celsius, this plate is up and pinned against here, and none of our cooling air leaves the enclosure. It's all recirculated around and around and around, heating up the enclosure. Between 10 degrees and 25 degrees, this plate will move back and forth. So basically, if it's minus 40 outside, it's still at least 10 degrees inside here, probably closer to 15 degrees. And if it's hotter than 25 degrees outside, all of your cooling air is blowing through and you get full engine cooling. In that way, we keep the 2,000 liter fuel tank warm, we keep the other engine warm, we keep all of our electronics warm, we keep the hydraulic oil for the light mass warm. Everything stays nice and toasty. The other thing you see inside here, you'll see it inside the whole enclosure, is all this perforated metal is methods of thermally and acoustically insulating this enclosure. We keep all the heat in so that we can better control how it operates, and we keep all the sound in. At 7 meters away, this unit runs 55 decibels or less. You can put it in a camp environment and it's quite quiet. Nobody's going to be annoyed by the generator running. So they're super, super quiet. Okay, I'll run back to the front here and we'll go over a couple more things before we do a shutdown. Okay, we've got the engine shut down now. We're going to prep the rest of it for transport. It's pretty simple. I'm going to turn the switch off, close this door, and latch it. We close the air intake cover, and latch it. Everything else is weatherproof. Don't have to worry about any of that, any water getting in anywhere. Now we'll go to the back end again. Okay, we're going to go to the engine disconnects. Switch them off. Very important to go and lower the light mass. Down and in place. And the last thing you're going to do is you're going to open this up and turn off the battery disconnect. And that's pretty much it. Thank you very much for watching. If you have any questions, check us out at www.validmanufacturing.com and give us a call if you have any questions. Thank you.